Okay, number 20. Our given differential equation is y prime equals x minus y. We're given a function of x, which is equal to c e to the negative x. Here c is a constant, plus x minus 1, and we're also given an initial condition. Okay, and this initial condition means that it's basically saying 0 comma 1 is, right, so this means 0 comma 1 is a point on the curve y of x. Okay, so here is our, again, initial condition. Here's a solution to this differential equation because they're saying verify. So if we quickly verify that, we get, okay, so we are substituting, right, this guy. So we have c e to the negative x plus x minus 1, and we're differentiating x minus c e to the negative x plus x minus 1. Here we are differentiating each term. All right, no need for the product rule since c is a constant, but we will use the chain rule for this part here. So c e to the negative x times the derivative of negative x, which is negative 1. The derivative of x is 1, and the derivative of a constant is 0, so we don't need to write 0. And here we're just distributing that x to the three terms. So it's really just changing the sign. So minus c e to the negative x minus x plus 1. And this guy is negative c e to the negative x plus 1 equals, this is nice because that's gone, negative c e to the negative x plus 1. And notice that the left-hand side and right-hand side are exactly the same. Or if you wanted to add, c e to the negative x to both sides, right, they're gone. So yes, you verified that that solution, that function is a solution, or it satisfies the differential equation. So now we want to find, so the really kind of central question here is we want to find a unique solution eventually, right? This is a general solution of the equation, right? Because c is arbitrary. It can be anything. So we want to find a specific solution, or in other words, a specific curve. Well, if you want to find a specific curve, you need a specific information, right? And this is your condition, right? 0, 1 has to lie on that curve. So with that said, let me just shrink this a little bit. So we have, I'm going to rewrite this, y of x equals c e to the negative x plus x minus 1. Use your initial condition here. So use your initial condition, right? So if x is 0, so, right, x is 0, so CE, and let me just so we can have a different color here. So my x is 0 to the 0, whoops, plus 0 minus 1. Okay, so what is y of 0? Well, it's 1 from our initial condition, and e to the, well, negative 0, I mean, it's still 0. If I give you, if I give you $0, I really don't give you anything. If I take $0, I'm not taking anything. So this is really just e to the 0. Well, anything to the 0 power is 1. So this is really just a 1. 1 times c is c, plus 0. And actually my initial condition, I believe, yes, my initial condition is 10. So let me just change that really quick. This should be, oh, I get a different color here. This should be 10. And this should be 10. Whoops. This should be 10. So we have, this should be 10. And we have, well, if we solve for C, C is equal to 11. Okay, so we found a C, which was the next sentence. Determine a value of the constant C so that such that y of x satisfies a given initial condition. So now we know C, so let's just substitute. Y of x equals, and C is 11. So I'm literally just substituting my, whoops. I am substituting my C with 11. E to the negative x plus x minus 1. Okay, so this curve is a unique solution to the differential equation, right? It's one specific solution. You can, and it says in the third sentence, you can use a computer or graphing calculator. The graphing calculator should be fine, TI-84, 83, to sketch several typical solutions of the given differential equations and highlight the one that satisfies the initial condition. So so use your graphing calculator, right? And again, this is an exponential function. This should be familiar what exponential functions look like. So if you take your calculator, I would take it out right now and just maybe pause this and go ahead and input this function, 11 times e to the negative x plus x minus 1. I would input that and maybe modify your windows if you need to. So go ahead and pause this really quick. Okay, welcome back. So when you graph your differential equation, and again, this is just a quick sketch, and your windows, I would probably do maybe negative 10 to 10 and maybe negative 20 to 20. And my differential equation is going to be in blue. So remember 0, 1, let's just say this is 0, 1, right, our initial condition. If you, when you graph this curve, right, it's an exponential function, right, a little bit funky, not, the asymptote is not necessarily 0, or it's not on the x-axis. So, right, your graphing calculator probably does a better job. So that's one solution. That blue curve, right, represents this algebraic equation, right? This is an algebraic equation. This is your y of x. But there are a lot of curves, hence a lot of solutions to differential equations. If you want to graph more equations, you would have different initial conditions. And actually, well, we know our solution, right? So if you just pick any C, C is, we had 11, so if C was 5 or 6 or negative 2, you would get different curves. So I'll write the different curves in maybe light blue, just so you can see the difference. Okay, there we go. So another curve, right, another solution to the differential equation, another solution to the differential equation, another one, and again, your calculator is going to do a much better job. Another one is actually, it goes right through here, and it looks something like this. And this is actually in your book, in your answers. Number 20 is in there, so you can kind of see this a little bit clearer. So hopefully that makes sense.